All right, welcome to section 2.1, chapter 2. In this section, as I make this video, I'm assuming that you've read through the book a little bit and know somewhat about frequency distributions and tables, although I'm going to hit the main parts of the homework as we talk here. So as we get into this homework, what you'll realize is that we want a way to organize data so that we can see what it looks like, how it's distributed, and that's why they call them frequency distributions. But they're really done in tables. And so as you saw, as you read through the book, or as you looked at the publisher provided instructional materials, either the PowerPoints or whatever, what we're going to do is take a big list of data and organize it into frequency tables. And so you'll have that opportunity as you're in the homework to do so. But essentially, we're going to be working with frequency tables. So I wanted to make sure that we had an idea of class width. Let me see where I can write that. I might not be able to write that in here. I think all of this is not allowed to write in there because of how I chose to do this. So let me bring this table up. So this is what a frequency table looks like. What it does is it groups things into categories. So what's happened is they've taken a big list of data that had actors' ages, and they grouped them into categories: 20 to 29, ages 30 to 39, 40 to 49, 50 to 59, and 60 to 69, and 70 to 79. Now they didn't extend beyond 79 or below 20 because there was nobody in there. So the first question, well, let me keep explaining this. The one that's in the first, that's in this very first area here, the very first category from the 20 to 29, that means there's one actor whose age was between 20 and 29. Because we don't have the original list of data, we don't know what that age was. It could have been 20, could have been 29, or anything in between, but there was only one age in there. 28 of the individuals that won Best Actor were between the ages of 30 to 39. 36 were between the ages of 40 to 49. 15 were between 50 and 59. And 6 were between the ages of 60 and 69, and so forth and so on. And so what we want to do is learn about this. So my first question to you is, how many people were involved in this? How many people did they keep track of? How many actors did they keep track of? Well, that's easily obtained. So what we want you to know is that these numbers in the frequency are not the data, they're just a count of the data. 28 individuals were between 30 and 39, meaning all 28 could have been 30? Probably not, but spread throughout there somehow. So the number of individuals that were involved, we would get if we added all of them up. And I'm doing that right now. So you'll have a calculator, and you'll add them all up. And I think I got 87 out of that. So the total number of people involved in the survey was 87. Let me add that one more time. Yeah, 87. So that's that's the number of people in the survey. I'm using a little n here. That little n stands for sample size. And we'll start to get you used to some notation as we move throughout. I don't think they're going to ask that question, but they may. But they are going to ask you about class width. The class width is the size of the class. That's the technical definition. And it may be tempting to say that each one of these classes are a class width of 9, but they're not. Each one of these classes have a class width of 10. So for our frequency table up there, the class width is 10. Why do I say it's 10? Look at the number of the size of the first class. It's 20, 21, 22, 23, 24, all the way up to 29. How many different possibilities is that? That's 10 different possibilities. Now that's the visual way to see this, but it's not the practical way to do it. The class width is what you get as you travel from one class to the next. So what's the class width as I travel from, and I should say from the lower class limit of one to the lower class limit of the other. as I travel from 20 to 30, you can see that it's 10. Okay, that it's 10 in size. From 30 to 40, it's also 10. We tend to keep the class widths exactly the same so that we get a good idea of how the data is distributed. So we can kind of see that this data pretty much peaks in the middle and tails off. They'll call that a normal type of distribution. But the class width, they'll have you look at a frequency table, identify the class width. The class midpoints, notice that there's an S there, so there's more than one, is the midpoint of each class, right? It's a set of all midpoints. So how do we get that? I need to know what's right in between that first class. So how do we get that? Well, you can either see it or you can average the two values. We want to go right in the middle. Between 20 and 29, that's 49 divided by 2. That's 24.5, right? Using our calculator. 24.5 is right in the middle between 20 and 29. Now, what's right in the middle between 30 and 39? So our first class midpoint, so if I were to list out the class midpoints, the first class midpoint is 24.5. The next one would be right in between 30 and 39, or 69 divided by 2, or 34.5. Now notice the difference between the two. To get from 24.5 to 34.5, I know you know it's 10, but what I want you to see is that it's the class width. So you don't need to do this every time. You need to get the first one and then just keep adding 10. Because that's how far they're going to be away from one another. So you should have the same number of midpoints as classes. So hopefully that's making sense to you as we look at this as a secondary reinforcement to what you've seen in the homework or on the instructor website, right, or in the book. The last thing is the class boundaries. Now the class boundaries, these are values that lie right in the middle of two consecutive classes. And by the same pattern, a value below the first class and after the last class. Okay. So that's again Jensen language. I want it different than what's in the book because I think it might help you. So remember what our category was: 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, and 70 to 79. Those were our classes. Now, what are the class boundaries? They're the values that lie right in between the two. So let me come and put them in red. What's right in between 29 and 30? 29.5 is right in between 29 and 30. What's right in between 39 and 40? 39.5. What's right in between 49 and 50? 49.5. Notice that all these red values lie right in between each class. They don't belong to the first one. They don't belong to the one that follows it. They are right in the middle. So that's that first part. Now notice how far apart they are. They're 10 apart. 59.5, 69.5. So right now, I've gotten the values that lie right in the middle of the two consecutive classes. Now I need to go get the other two. I'm going to put them in a different color just so I can highlight what they are. I'll put them in black. Maybe that would be easy to read. I'm worried about the green being easy to read. So notice what's happening every time. 29.5, 39.5, 49.5, adding 10 each time. So the one that lies beyond the last class is 79.5. By the same pattern, adding 10 or adding the class width, a value, and I just did after the last class. Now if I go backwards, you'll notice that we're subtracting 10 every time. And so what do I get back here? 19.5. The class boundaries, I'll go back to the blue. The class boundaries for this is the set. So this is the class, I'll put CB for class boundaries, is 19.5, 29.5, 39.5, 49.5, 59.5, 69.5, 79.5. That's the values of the class boundaries. Awesome. Okay, what we can do, I think we can definitely do all of that. Now I want to give you a heads up. Let me just make up a new one. Let me make up a new frequency table. One that goes from 0 to 2, 3 to 5, 6. Now notice what's happening here. I'm adding 3 every time. 6 to 8, 9 to 11, 12 to 15. I need to keep them adding. And so that last one's wrong, right? Adding 3, 6, 9, 12, adding 3, 2, 5, plus 3 is 8, plus 3 is 11, plus 3 is not 15, right? Making that mistake just to have us pay attention there, to 14. And then I'll make up some frequencies. So let's suppose that these are ages of a car. Ages of cars. And I observed 15 cars that were brand new, 1-year-old or 2-year-old. 14 cars in the parking lot that were either 3, 4, or 5 years old. 3 cars between 6 and 8 years old. 2 cars between 9 and 11. And 1 car between 12 and 14 years of age. Now if I ask you to find the class width, do you see what the class width is? It's just a single number. The class width is not 2. It's not the difference between 2 and 0 and 3 and 5. The class width is how far do I go? Does it take me to go from 0 to 3? And the answer is 3. From 3 to 6 is the same 3. There's usually just one class width. That's at least the way we'll do it. And it's a practical way to do it as well. The next thing I want to make sure is, are you good with the class midpoints? Do you know the number right in between 0 and 2? Maybe, I think we all might know it, right? But maybe you have to add the 0 and the 2 and divide by 2 to get the 1. Now you shouldn't look anywhere else. You don't have to keep doing that every time. You can just keep adding 3 to get 4, 7, 10, and 13. You should have the same number of midpoints as you have classes like we do. And finally, the class boundaries. The class boundaries, it's going to be a set of numbers. Well, right in between 2, and I'll put them in red so that they stand out. Right in between 2 and 3 is 2.5. Then there's 5.5, 3 later, plus 3, 8.5. And yeah, it does lie right in between. Plus 3, 11.5. Why am I saying plus 3? So that you remember to do it to get the number that goes after the last one, 14.5. And then also before the first. 14.5 minus 3 is 11. 11 minus 3 is 8. 8 minus 3 is 5. 5 minus 3 is 2. And 2 minus 3 puts you under 2.5 minus 3 puts you underneath 0. And so I wanted to give this as an example because it's completely fine for your class boundary to be negative. I know it's not a number that can be achieved, but neither is 2.5 or 5.5. Not the way I collected the data. And so these class boundaries don't belong to any of those groups because they're right in between. And we use them for a very specific purpose that's actually right in 2.2, so it's nice that it's there. The other thing that happens is frequency tables. I'm sorry, relative frequency tables that I have written up here. I'm going to come up here and see if it will allow me to not move that around. Let me copy that. I don't know if it's Oh, let me drag that out. Let me copy that and see if it will allow me to paste that down here. Okay. The relative frequency table is a frequency table that shows relatively how big the class is. So relative frequency is percentage. That's all it's asking for. The percentage of data that lies there. And so I think some of your Chapter 1 skills review will be finding percentages. So we need to figure out what percent of the data lies in each one of those classes. So a relative frequency table is always formed from a frequency table. Okay, and so we're going to figure out what percentage of data lies between 20 and 29. Figure out what percentage of data lies between 30 and 39. Okay, so the relative frequency table was 1 is the frequency, but the relative frequency is the percentage. Well, how are we going to get that? We're going to take 1 and divide it by the total number of data points. So we're going to take our 1 and divide it by 87. And we're going to get, if I look at 1 divided by 87, I'm going to get 0.0115. Right? Now, it's up to you how you want to round. There's no consistency in our book. So I would say that this is about 1% of the data, and that's what I would report. Then we're going to say, well, 28 out of the 87 values are here. And if I look at it, 28 divided by 87, I see that this is 32%, right? Rounded. And you can just keep rounding those guys. And so that was 28. And you'll just keep doing this all the way down. That's what a relative frequency table is. It just gives the percentages. All you need to show me is the percentage. I just want to show you where I'm getting the calculations from. 36 divided by 87. So each one of those categories gets divided. And here it's about 41%. They should technically add up to be 100% in the end. Sometimes it's not quite there because of the rounding that we do. And if I take 15 and divide by 87 just to finish out, 17%. And that, so what I'm showing in this last part is what I'm okay with, just the percentage being written down. And 60 to 69, there were 6 in there. 70 to 79, there was 1 in there. So I already know the 1 is 1% because that's what was in the first category. 6 divided by 87, about 7%. So 1%, 32%, this is the relative frequency table that they'll show you in the book. It's just putting things out in percentages so that we get a quick picture of the size of each one of the classes relative to the size of the data set. So it's really good. So if I told you, that there was, if going back this one, there were 15 cars out in the parking lot between the ages of 0 and 2, and that's all you knew, you wouldn't know how relatively big that was. But if I told you that it was a certain percentage, like 25%, you say, oh, that's a fair chunk of the cars. So keep that in mind. All right. Good luck in this section. Let me know if you have any difficulty.